a bunch of numbers, and I'm trying to look for a pattern. What is something I can start doing? Okay, so I see it in the chat. Lauren says that we can divide. So what does it mean by divide? What do I divide? Where do I go? What numbers should I start with? So we're trying to check to see if it's exponential, right? So Guillermo, x1, x2, that y2, y1, x2, y, whatever, x1, that's linear. So that's different, that's for slope. Right now we're checking if it's exponential. So in order to do that, Lauren's got us, we got to start dividing the numbers. So for example, I can go to these two numbers, the first two, but should I be doing 22,000 divided by 19,360, or should I do 19,360 divided by 22,000? Should I go from top down or from bottom up? Top down? What do you guys think at home? Dinara agrees? Lauren, what do you think since you started this? Top to bottom? Oof, nope. Everybody got it wrong, actually. It's actually bottom up. So when you're dividing, because it's division, you don't want to go from top to bottom, you want to go backwards. You want to go from bottom to the top. So we go this way. So I want everyone, calculators or phones, whatever you got, take it out. And we're gonna divide. So 13,193.29 divided by 14,992.38. Go from bottom all the way up and see what you get. So starting with the first two. Shout it out when you've got it. What do you got? Oh, all right. I already got some in the chat. Good. 0.88. Okay, now we're going to do it again. And you want to see if you end up getting the same number. That's the whole point. We want to check to see if we get the same answer. So now we go again. This time 14,992.38 divided by 17,000. Blah, blah, blah. See what you get. And you can round. Same thing, 0.879. Well, 0.879 rounds what? Rounds to what? 0.88. You get the same decimal. Let's do it one more time. You always want to try it 3 times, just in case. One more time, 17, blah, 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 divided by 19, blah, blah, blah. Same thing, yeah, 0.88. So this gets me the same value every single time, and we were dividing, so is this linear or exponential? This is exponential, good. If you remember from last week we were checking to see if things were linear. So that's the big difference. Exponential is when you divide. When you divide and get the same answer every time. That's exponential. But linear is when you have to use the slope formula, kind of like Guillermo said before. So if I was asking you, is this linear? You would have to go, let me move this around. You'd have to go and use the slope formula and then see if you get the same answer. So like if I wanted to do slope formula, I would do 19,360 minus 22,000 over 2 minus 1. You guys remember that from last week? Yeah. So if you do this, would you get the same answer every time? What do you guys think? Using the same table, would I get the same answer if I use the slope formula? Ijara says no and Lauren says no. Oh, Ijara says she tried it already and it didn't work. Yeah. So let me just show you really quickly. If I try it, 19,360 minus 22,000, I get negative 2,640. And then if I do it again, but this time I'm going to use these two numbers. Okay, so this would be 17,036.8 minus 19,360 over 3 minus 2. This time I would get, let's see, 036.8 minus 19,360. I get negative 2,323.2. Do I have a constant rate of change? No, right? Those are completely different numbers. So if you tried this and then you got different numbers, then you know right off the bat that this is not linear.
Good morning, teachers and students. Teachers, at this time, please review the email of students testing today and release them to their testing location. Please also review the relocation email that I sent and move also to your relocation areas. Thank you.
All right. Okay, so those of you who are testing, if you're not sure where you're going, you can ask me, but otherwise you guys are free to go. Yeah, you can go right now. Raymond, you too, right? Anybody else? No, right? All right, good luck, guys. So as a conclusion, we know that it's not linear, but it is exponential. So we're done with part A. All right, part B, how is the price changing each year? Is it a constant rate or is it a constant percent rate? Constant rate or constant percent rate? So Jara's asking, constant rate is linear, right? Yes. So constant rate would be linear. So in this case, it's got to be constant percent. Percent is exponential. And yes, they're taking their reading FSA. So that's what it is. This is a constant percent rate. And the constant percent rate is the number that we got. We got 0.88. That's our constant percent rate. All right, what was the starting value of the machine? What? Yeah. So it started at 22,000. That is correct. So when I ask you for the starting value, usually you want to look at the y-intercept, right? But in this case, there is no y-intercept because they're talking about it like in the first year, it was 22,000. So you can think of that as the starting value. Instead of having it as a 0, they put it as a 1. But that's okay. You always want to just look at the top number. $22,000. So we know it started at 22,000. We know the percent rate was 0.88. So now we can write an equation. And again, we're reviewing this. So if you don't really remember how to do it, that's okay. But as a reminder, for exponential functions, it's going to be a times b to the power of x. Who remembers, what does a represent? What does a represent? Good, Lauren's got it. It's the starting value. So A is the starting value. So what do you guys think B is going to be? The rate, the percent rate. So we have two numbers, right? We have 22,000 and 0.88. 22,000 is the starting value and 0.88 is the percent rate. So f of x equals 22,000 times 0.88 to the power of x. Okay. Now, again, we're going to review all of this. So at this point, let me know what questions you have. I'm going to answer one from the chat. Somebody asked, doesn't it usually start at 0? And the answer to that is yes. Usually it starts at 0. However, in this case, we are going to go with, because think about price, like when you're pricing something, when you're telling, oh, the price of this thing was $5, you don't really say that the price was $5 on year 0. You start counting at 1, because when we count time, we always count with whole numbers. We don't really count from 0. Does that kind of make sense? This one is a little bit confusing in this case, but just know that for this example, we're not starting at the 0, we're starting at the 1, because at 0, it would have just been 0. You got to wait until a full year passes, and then you can say, oh, okay, it was $22,000. Any other questions? Okay, cool. So let's get going with the review. So like I just said, this is how we write exponential functions. So A is the y-intercept, or sometimes we can say that that's the starting value. And B is always the growth factor, which is also called the percent rate. So I want everybody to take a look at this graph and take 10 seconds to identify what is the y-intercept, and then find another 2 perfect points. So the y-intercept plus 2 other perfect points. Start thinking, and then when you're ready, you can shout it out. Yeah, I can zoom in a little bit. So y-intercept, what is it? Okay, Guillermo's got some perfect points for us. Ijara has our y-intercept. Good. Y-intercept is 1, 0, 1. And then Guillermo said, okay, 1, 2, yep. And then 2, 4. Good. So I have my y-intercept plus 2 other perfect points. And all I'm going to do is I'm just going to put them on a little chart. So I have 0, 1, 1, 2, 2, 4. From my table, from my little chart, can anyone identify the growth factor? The growth factor. What is the pattern when I go from one value to the next? Good, it goes by 2. So in other words, am I multiplying by 2 or adding by 2? Good, times 2, times 2, times 2, multiplying. So in that case, my growth factor, my B, is 2. And what was my y-intercept from the graph? A is 1, B is 2. So I can write an equation for this graph. So I'm going to go ahead and write it. My equation is going to be y equals 1 times 2 to the power of x. But what can I do with that 1? Do I need to write it? It's a coefficient. Do I need it there? No. So I'm going to simplify. This is just y equals 2 to the power of x. That is my equation. So let's just do a little bit of a review. Exponential functions. Exponent. They have the word exponent in it, right? So exponential functions, you can always identify them because what does the equation have in it? An exponent, yeah. And what is the exponent? It's x. So if you see an equation on a test and you're not really sure what type of function it is, look for the exponent. If your exponent is an x, or maybe sometimes it's a t, either way, you know it's an exponential function. And if it looks like this, I mean, this function is very classic exponential function. It kind of like starts off really, really, really slow, and then all of a sudden it's going to shoot up, right? So that's what they all are going to look like. Do I have any questions so far?
Yes.
Yes, what's your question? If on the, wait, say that again. If, okay, good question. So Guillermo asked if you're putting an answer in the test like this and you put a 1 in the front, is that going to be wrong? My answer to that is no, it's not wrong, but they might take like 1 point off just because you're supposed to keep it as simplified as possible. Okay. Do we plug in for x? No, we're not going to plug anything in. We're just going to leave it. However, Lauren, here's a follow-up question. What if I was like, let's say this graph represents money. What if I asked you, how much money am I going to have after 4 years? Then you would plug in 4 to figure it out. So if you have to read the question carefully. If the question is just saying, write an equation, you're just going to write an equation. But if the question asks you to plug something in, then you're going to plug something in. It just depends on what you read in that problem, okay? So in this case, we're not plugging anything in. Any questions, any other questions on this graph? Okay. Now let's talk about word problems. Let's see how you can identify when something is exponential versus linear. And you might recognize this because we did see this, a very similar type of problem last week. But start taking a moment to read all of these examples and start coming up in your head with your answers. Is it going to be linear or is it going to be exponential? Take about, I'll give you guys a minute. Ijara, we did a very similar one the other day, but not the same exact one. All right. So I'm seeing a few answers coming into the chat. Keep sending them. I'll give you guys 10 more seconds. If you have answers, you can send them now. Good, okay. All right, let's take a look. Number 1, a savings account accumulates no interest, but receives a deposit of $500 each month. Linear or exponential? Shout it out. What do you guys think? 1 vote for linear. 2 votes for linear. 3 votes for linear. Yes, that is definitely linear. Remember that interest is exponential. But what does it say? There's no interest. So if there's no interest, you're linear. If there is interest, I'll write it down. If there's interest, it's exponential. Okay, number 2. The value of a house increases by 1.5% each year. Linear or exponential? Good, expo. Nice. What gives it away? This one's easy. Why is it expo? Good, the percent. Percents are also exponential. The temperature increases by 4 degrees Fahrenheit every hour from 8 a.m. to 3 p.m. one day in July. Linear or exponential? I have 1 vote for linear, 1 vote for expo, 2 votes for linear. Are there any percents? Yeah, there's no percentages. There's no multiplication words. There's no interest. It has to be linear. What about number 5? Every 240 minutes, 14% of the rat population dies. Good. Okay, that one's easy. Exponential as well. Kind of sad for those rats. All right, and then last one. Each month there are 5 fewer bales of alfalfa in the barn. Linear. No multiplication words, no percentages. It's linear. So exponential functions, we always look for percentages, multiplication words, and then interest is the one other thing that's involved with exponential functions. Any questions on how to identify from a word problem? Yeah. Not decimal, percent, yeah. But yes, so percentages, interest, and then the last thing would be like if it said it doubles every day, it triples every day, those are multiplication words. So that would also be exponential. All right. Cool. Now let's kind of like what we did in the bell ringer. We're going to figure out if it's growing linear or if it's growing exponential. So remind me one more time. If I want to find out if it's exponential, what do I have to do? Find that percentage by doing what? Dividing. From where to where? Bottom to top. All right. So this is where y'all gonna sit there and do some math for me while I watch. Let me split you guys up. Everybody at home, if you're at home, you're doing painting A. Everybody at school right here, you guys are doing painting B. Why is that not fair? You're all doing the same work.
There's so many people online.
No, there's not. There's really not that many people at home, at least today. Okay, so go ahead. Everybody, you're doing either painting A or painting B, and you're just going to start dividing. Divide, and write down your decimal each time so you keep track of what you get. Go ahead and it takes a moment, so I'll give you guys like 2 minutes, a minute and a half. So from the bottom up. From the bottom to the top, yeah. Guillermo, round close, do 2 decimal. 2 decimal places. To the nearest 100th. I should have been clear about that. Round to the nearest 100th. Okay. My timer just went off. So let's go through it. So for number 1, or not number 1, but for painting A, I see a few students already sent it in the chat, but one of you guys, can you put it in public? What did y'all get when you divide? Go for it, Jara. 1.05, 1.05, exactly. 1.05. Every single time, that's what you get. Sometimes it's a little bit off, but it always rounds to 1.05. All right. How about you? 1.02? Yeah? Yeah? Good. 1.02. But it changes. Oh, okay. So what happens? Yeah. So is it always, let's see. Let's do this one together. Those of you at home can also do it so we can check. So the first one, 16,561 divided by 16,236. It's 1.02 like 00. So that one's good. The next one, 16,236 divided by 15,918. I got 1.0199. But does that number stay like that or does it round up? It rounds up. So it's still 1.02. Okay, so even if it's a little bit different, as long as you can round it to the same number, you're good. Does that make sense? Okay. So 1.02 versus 1.05, which one has a greater rate? Painting A or painting B? Which one has a greater rate? Is painting A. So we know painting A is going at a larger rate. Is it increasing or is it decreasing? It's increasing, right? It started at $15,000 and then by 5 years later, it's almost at 20,000. So it's increasing. And is it a percent rate or just a constant rate? Think about what type of function is it? What did we just prove? It's exponential, yeah. Since it's exponential, it's going to be percent rate. So putting it all together, value of painting A grows by a larger percent rate than painting B. That's the answer choice C. So those are the key words you got to look for. Percentage is exponential. And if it doesn't say percentage, that's not the right answer. So A and B were automatically out. Questions on this one? How do we feel about doing that math and rounding it? Do you feel okay? Yeah? No questions? All right. Okay, now let's think about this. Let's think about what's on this graph. What are the two types of functions on this graph right now? Go for it, Bianca. Linear one is going straight, good. And then the other one's exponential, awesome. So this one's linear. And then the other one, we just went over it, right? This is what exponential looks like. It kind of curves, upward. Now, here's the question. We don't see what's going on further up here. Like we don't know what's happening up there. But what's gonna eventually happen again? Yeah, so down here, they meet one time. And if I keep them going, they're gonna intersect again. Somewhere maybe like up here, right? Okay, when that happens, are they ever gonna meet again after that? No. So which one is gonna end up on top after that point? Blue or red? On top. Think about. I hear it's like half and half right now. It's kind of hard to explain, but let me try to. You think it's red? I'm hearing red and blue from both places. Today, what do you think? You think red? Bianca, what do you think? Red? Blue. David's going for blue. So the red one's going to keep going straight, yeah. And then the blue one. Yeah, okay, so I'm hearing both sides. Lauren's like, we went over this. Yes, so think about, okay, do you guys remember when we first started learning about this? And I gave you that silly example about like who was it? Elon Musk is gonna let you mow his lawn, and you have two options.
Yeah.
Do you remember that? Okay. There was one option that was linear and one option that was exponential. Which one was the winning option at the end?
Expo.
Expo always wins. So let me draw. Let me draw it so you guys can see what I mean. It's a little bit hard to see, to understand it, but if I keep this going, it's gonna look like that, right? If I keep the red one going, it's gonna look like that. Now the question is, which one is growing faster? Which one's shooting up faster?
Blue.
You see how blue is going faster than red? It's farther to the right, but if I like,
Oh, yeah. That's in time.
that's time. Which one's time is x-axis, money would be the y-axis. So you're not talking about which one's going further to the right. I want to know which one's going higher up. Does that make sense? Does that clarify things? Okay, which one's going higher up? Blue is going higher up. So blue is the one that wins. So that's where it gets kind of confusing. But if you remember this, just remember this, Expo always wins. Always. Because exponential is doubling, it's going real, it's like growing really, really fast. Linear is kind of like a train, like it kind of has a constant speed, it keeps growing at the same speed. But exponential is more like a rocket ship. It's just gonna like shoot up really fast eventually. That's the difference. Do I have any questions on that? Okay, cool. So if I answer this question, which one exceeds the other? The exponential function exceeds the linear function. It's gonna be D. Okay. Any questions on that concept? I know it's a little bit weird to like grasp, but okay, cool. All right. Now writing an exponential function equation, we kind of did this in the bell ringer, so let's just review it. So we know it's f of x equals what? What is the general, what are the letters I use? A and B, good. A times B to the power of x. What does A represent? Good, y-intercept. What does B represent? The rate, the percent rate. Okay, so I have a table, let's identify those values. What is the y-intercept? Good, 2. What is the percent rate? Now in this case, you can see the pattern pretty easily, but remember that you can always divide to find out. So if you're not sure, just go to the bottom and divide and see what you get. 4, good. And if you do it each time, you're always gonna get 4. Right? 32 divided by 8 is 4. 8 divided by 2 is 4. So our percent rate is 4. So when I want to write my equation, it's going to be f of x equals 2 times 4 to the power of x. And can I get rid of any of them, or is that my simplified final answer? Simplified, right? Can I do this?
Yes.
You said no first, then you changed it to yes.
No.
Why not? Exponent. Okay, so think about PEMDAS. What does PEMDAS say? What do you always have to do first? Exponent comes first. So I don't know what the exponent is, so I can't do it. So I gotta leave it the way it is. You can't multiply those two. If it was a 1, yeah, if this was a 1, if it was 1 times 4 to the x, then you can just leave it as 4 to the x. But since it's a 2, we can't get rid of it, we can't use it, we gotta leave it the way it is. Now, they also sometimes they write it like this. So just, you can see it both ways. Mm-hmm.
This does still count.
Does the what count?
Put that in the test, but the second possibility still true. Would it count?
It would still count. Yeah, you can write it both ways. And you'll see it both ways too. So just know that because multiplication, you can use parentheses or you can use the little dot. So it doesn't matter which way you write it. All right, questions on how to write an equation for exponential functions. A times b to the x. Good. All right. What about from a graph? Very similar. It's the same equation, y-intercept and rate. And Ijara, to answer your question, the exponent would go outside of the parentheses, not inside. All right, A, y-intercept, 1. B, percent rate. So in order to figure it out, yeah, Guillermo's getting us started. In order to know the percent rate, you want to just look at the next couple values. And it might help to make a table, because if you have a table, you can see it a little bit better. So it's 0, 1, 1, 2, 2, 4. So what is my growth rate? What's my percent rate? What's the pattern?
2.
2 times 2. Good. So my percent rate equals 2. So what's my equation? Write it out. Go ahead. 2 to the power of x, right? So remember, it is technically 1 times 2 to the power of x, but we don't really need to include the 1. So it's just going to be 2 to the power of x. All right. Any questions on how to write it within? Yeah. Okay, good question. His question is, do you have to divide it or multiply it? So basically in this problem, it's very easy because you can see the pattern easily, right? You can look at the numbers and it's like, oh, okay, it's times 2. Simple. But if you're not sure, that's where you would divide. So if I divide, what's 4 divided by 2? 2. 2 divided by 1? 2. So dividing is useful if you're not sure what the pattern is. But if you can just see the pattern with any table, anything at all. Any other questions? All right, cool. Okay, let's check this out. Transformations. So this is the same graph we just saw right here. 2 to the x to the power of x. Which one is the graph of f of x equals 2 to the power of x plus k if k equals -2? So if k equals -2, what's happening? It's going in what direction? Left or down? Down. Yeah. Remember that k is your vertical transformation. So it's either going to go up or down. But since it's negative, -2, it's going to be going down. So now take a look. The original one was crossing the x-axis, the y-axis at 1. Yeah, it's -2. So yeah, is it A or is it D? Count carefully. It started where? Originally it started at? No, it started at what? At 1. So if I'm going down by 2, where do I end up? There you go, A. I end up at the -1. So let's quickly, I just want to make sure we review this because it does come up pretty often. So what's happening is that K is going to move your graph downward. And this equation, it says K equals -2. So this equation would be 2 to the power of x minus 2. Now remember that 2 to the power of x technically has a hidden invisible 1. in front of it. Right? Remember how there's technically a 1, but we just got rid of it. So this is basically saying that you start at 1 and you're going to go down by 2 units. So 1 minus 2 is how we get -1 right here. So this is going down by 2 units. What would be answer choice B? Where would it be from the original? Where did it go? Say that again. It's at the 2. So example B is at the 2. But where did we start from? 1. So how many units did it move? 1 unit in what direction? Up. So B would be f of x equals 2 to the power of x plus 1. And then D, how many units did it move from the 1? Minus 3. So D would be f of x equals 2 to the power of x minus 3. Okay, now C is a little bit different because C moved not only up, but it also moved to the left. I don't know if you guys can see how C is like off center. It's off to the left a little bit. So we're going to skip that one because that's not something that you need to know. So don't worry about that one. That's in the future. Yeah, you'll see that again in algebra 2. But A, B, and D definitely might come up. So it's important to make sure you know how to do that. Yeah, if you had this exact question on the test, you can easily get rid of C because you know that it's either only going to move up or down. It's not going to move left or right. But the other 3, you would have to figure out which one's the right one. Questions on this one? We're blazing through this, guys. Good job. Okay. Oh, okay. So we kind of just talked about this a little bit. So I want to see how much you guys can figure this one out on your own. What would be the y-intercept of the graph of the function below? F of x equals 3 to the power of x minus 9. Think about it for about 30 seconds. All right, I see some guesses. Guillermo and Lauren both say it's B. Think about if you agree or disagree. David agrees.
I know it's B.
You know it's B. You're not even guessing. Okay. All right, let's check it out. So this is telling me this is k equals -9. So what is that telling me? How many units did it go and where? Down 9 units. But where are we starting from? From 3? No, not from 3. From 1. How come it's from 1?
Oh,
Yeah, it's invisible, but it's there. 1. This is 1 times 3 to the power of x. So the original y-intercept is 1. So I'm going down 9 units from 1. So where do I end up? -8. There you go. 1 minus 9 is -8. Now, let me change things up. Let me give you a different example. What if it was this? What would be the y-intercept? What is it? -7. This means it starts at 2 this time. So 2 minus 9 The original y-intercept is 2. And I'm going down 9 units, so the new y-intercept would be -7. So remember, the A tells you where you started from, and the K tells you where to go from there. And if you don't see an A value, then it's a 1. You always have to look out for invisible ones, because if they don't show it, you have to remember it's there. They will definitely try to trick you like that, yeah. You gotta be careful. Does anyone want me to show one more example of this? Yes? Okay, I'll do one more. Do a what? A big number? Okay. So what is the y-intercept? Let me think of a good one. Yeah. So there's a decimal. Is that decimal the A or is it the B? So what's the A? 1. Oh, so can I rewrite this? I can rewrite this as 1 times 1.05 to the power of x. What's the -12? You guys tell me. What does the -12 tell me? Where to go. So where am I going? Up or down? Down from where? From 1. So where do I end up? If I'm starting at the 1, where do I end up? There you go. Lauren got it. Jari got it. So the y-intercept would be -11. So it doesn't matter what this number is, because if you have a 1 in the front, that's all you got to do. You got to remember it starts at 1, and then I go down to the 12, or down 12 units. Any last questions on that? Yes, question?
Like a harder one.
A harder one? You guys want a real challenge? I can give you a real challenge. Maybe at the end. Maybe at the end. But it's not going to be that hard. They're not going to make it that hard. On the test, they won't make it that hard. They'll make it kind of like this one. So it won't be that hard. Okay. What about on a graph? So think about this one. You should try to put everything all together now. I'll give you a couple seconds. 30 seconds. Shouldn't take you longer than that. So don't try to overthink it. Just remember what we just talked about. All right, we all agree it's D. I want to give everyone a chance though. More votes for D. Going with Guillermo on this one. Okay, let's see. So the trick to this first is, okay, what's the y-intercept? 2. Okay, so the y-intercept is 2. Then you go to the graphs and you have to tell me, or you go to the answer choices, what would be the y-intercept of this one? 1, the invisible 1. What would be the y-intercept of this one? 0, good, because what, how is that 0? 1 minus 1 is 0, good. And then what would be the y-intercept of this one? 2, good, because we're going up from 1. We always start at 1. So if I'm going up 1 more unit, I get to the 2. And that's how I get answer choice D. Now B, what's wrong with B? Yeah, it's in the wrong place. It's an exponent. So in B, they put it in the exponent, which would make it actually, that would make it move. Who can guess? Where would that one go? Up, down, left, or right? Okay, left or right? Left or right?
Left.
Left, yeah. So B would move 1 unit to the left. That's how that's how you do that. But again, you don't need to know that. You just have to know that that's not what you're looking for. All right, any questions on this one? This one is a good question, but see how, once you understand it, it gets pretty easy to just do it. Yeah, go ahead. Okay. Next, ooh, who remembers this stuff? End behavior. This is where, yeah, it's been a while. It's been a while. I'll let you guys think it out for a moment. I'm not going to give away the answer yet. Take a look. You thought you were doing so well, right? If you know the answer, you can send it in the chat. If not, I'm giving everyone a minute to think about it again. Think about how this works.
Basically, you got it.
You forgot everything about this. Okay, that's my timer going off. So I'll do a quick review. I'll do number 1 and then you guys try number 2. For number 1, first thing, as x approaches infinity, is that telling me to go to the right side or the left side?
Right.
To the right side.
Wow.
Why the right side?
Not
Yeah, because it's positive infinity. So positive infinity is on the right. So I go to the right side of my graph. What's happening here? Where is that graph going? Up. What do we call that when it's going up? Hi. Nice to see you. What's up?
Where you been?
I'm good. How are you?
Good, good, good.
I-
How come you wait for me to come back?
I'm fully vaccinated now, so I was like, I feel good about that.
What's that? To go to med school?
Yeah. Yeah, Temple.
Betty, right?
Yeah.
Don't be fat. She's gonna have
She
to
is.
straighten out. Good seeing you.
Good seeing you too. Bye. All right. So on the right side of my graph, it's going up. And if it's going up, it's going towards infinity. So that's what I write in my blank. As f of x approaches infinity on the right side of my graph. Now what's going on the other side? Now it's easy. See what's going on the other side? Negative infinity. So that's the left side. What's happening on the left side of the graph?
It's going down.
It's not. Is it going down? It's trying to reach the x-axis. So it's approaching what? 0. Good. So there you go. Now try 2. Try number 2. See if you can figure that one out. Yeah, it's similar to the first one, but it's kind of upside down. Reversed, yeah. Take another 10 seconds. Have an answer ready to go in your head. All right. So let's start with the right side. Where am I going on the right side? Down. So when I'm going down, I'm going, good, Lauren put it in the chat, I'm going to negative infinity. Now on the other hand, what's going on the left side? It's going towards 0, exactly. 0. So on the right side, it's going down towards negative infinity. On the left side, it's going to 0. Anytime when it looks like it's going to touch the x-axis, that's 0. If it's going straight up, it's positive infinity. If it's going straight down, it's negative infinity. So this one's always like that. This is always what people struggle with a lot. But do I have any questions on that? No? Anyone at home? Questions? Will they put this on the test? You never know. It's possible. The thing about the test is there's a lot of stuff that we learned, and some of it is on it, some of it is not. So you never know. Yeah, it'll be all anything from all year. Yeah, you got to be prepared for anything. Okay, this is just another of the same example, so I'm going to skip it for now, but we can come back to it. What time is it? Oh, we got time. Okay. Finally, exponential growth and decay. So this is our word problems. Would anyone like to read? Anyone at home? We can hear you if you want to read. I put the volume up. No one's feeling it today? See, the fun thing about being in school is I can now call on you if I want to. I could also call on the online kids, but. All right, Karina raised her hand. Karina, go ahead. We can hear you.
The amount of a certain radioactive substance increases by 15% every hour. If a sample starts with 100 grams of this radioactive substance, which function represents the amount of radioactive substance left after X hours?
Thank you. Awesome. So we're going to highlight a couple things. What should I highlight? %. Good. Decrease. Good. Very important. 100 grams. Good. All right. That's pretty much everything we need. So it's decreasing by 15%. What do I need to do with that percentage first? Not quite, not yet. So I know it's going down by 15%, but anytime I have a percentage, if I want to use it, what do I have to do to it? Lauren says 0.15. What did Lauren just do? Not the veg. She turned it into a decimal. Turn it into a decimal. So that's the first thing you always got to do that first. Turn the percent into a decimal. So 15% becomes 0.15. That is my rate. Now, is it increasing or decreasing? What did we say? Decreasing, it's decaying. Okay, that's going to be important because we have a decay situation. So this is what the function is going to look like. It's going to be a times 1 minus r to the power of t. What does a represent? Y-intercept, starting value. What's r? The percent, yeah. Percent rate. So we can put all of those numbers in because my starting amount, it starts with 100 grams. And then when I plug it in, so this is 100, 1 minus 0.15. What is the last thing I have to do? Do the math. So in other words, 1 minus 0.15, what do I get? not quite a gyro. We're subtracting a decimal. So think about money. $1 minus 15 cents. 0.85 to the power of t. That is my final answer. Now remember that when you're decaying, I think Lauren said it a couple minutes ago, if the number is less than 0, that's how you know you have decay. So decay is when that number is less than 0. If that number is greater than, or not less than 0, less than 1. If that number is greater than 1, what's happening? Growing or decaying? Growing. That way. So we're going to do a few of these, but do I have any questions so far? The first thing we do, turn it into a decimal. Then you got to plug it in. Now, when it's decaying, we subtract, but if it was growing, what would we do? We would add. Okay, so you have to remember that if it's decaying, you subtract. If it's growing, you add. So let's see if we have another example with growth. Yeah, what's your question? What happens if it doesn't show a percentage? It will. It will. Because it has to. Because if it's not percentage, then it's not a function. It's not going to be an exponential function. So if they don't show any percentages, then it's not exponential. It's something else. Okay, let's try this one. So let's see, who's going to read next? So Karina was so kind and she read last time. This time, I think it's time for somebody here to read. David, can you read for us? But David, I want you to go on off mute. I'm going to mute myself and then you read.
The value of a certain stock has increased 5% per day for the past 10 days. The initial price of the stock was $30 per share. Which equation describes the value of the share price of the stock as a function of N, the number of days elapsed during the 10-day period?
Thank you. Okay. So very similar to the previous problem, but before you guys do this one, I have a request to go back. So I'm going to go back really quick. You can take a picture. And the next one is very similar. So if you can figure this one out, you should be able to do the other one pretty easily. All right, we're good to go. Go ahead. Send me your answers in the chat when you think you have it. Take about 15 more seconds. 20 more seconds. Okay. All right, let's take a look. So I'll highlight my important info. 5% is my rate, and it's decreasing. My starting amount was $30 initial. Okay. So I know it's going to be f of x equals, I guess technically this is f of n. F of n equals a times 1 minus r to the power of t. So that's a, wait, what's a? A is my initial amount, 30, good. 1 minus what? 0.05. 0.05 comes from 5%. So 5% as a decimal is 0.05. Good. Well, now I just got to do a little bit of math. What's 1 minus 0.05? 0.95. For me, it might be really helpful for you. For me, it's very helpful to think about it like money. $1 minus 5 cents, 95 cents. That's the power of 9 by that. So it's answer choice A. Questions? Yeah? So yeah, if you write it this way, like 30 times 0.95, like that. Yeah, that's still fine. Like I said, you could write it both ways. Yeah. Any other questions? All right. Let's do another. I'll read this one because it's a little short. Population growth of a country is modeled by the function below, where t is time in years, based on the model, which is true about the country. So now I want you guys to start putting it all together. Try it on your own. I'll give you guys 30 seconds to read and pick an answer. Careful, B and D are not the same. So this is a little tricky because there's 10 million or is it 100 million? Is it 10 million or is it 100 million? Okay. No? Okay, take another couple seconds. I see votes for A, for B, and for D. All right. Okay, final answers locked in. Let's take a look. So first thing, this situation right here, 10 to the power of 7. 10 to the power of 7. So when you have 10 to the power of a number, that number is how many zeros you're going to add on the end. So we're going to count. So I write 10 and I'm going to add 7 zeros. 1, 2, 3, 4, 5, 6, 7. Then I'm going to add every 3 zeros, I add a comma. So what is that? 10 million or 100 million? That's 100 million. That's 100. So it's 100 million. So that's the first thing. So it's not A or B. So in that case, if you chose A or B, I want you to rethink your answer and now think of which one is it going to be. Is it going to be C or is it going to be D? I'll give you guys another 15 seconds. Okay, rethink your answer. And if you are changing your answer, send me your new one. Okay, good. We're feeling good about our answers. So we know that 1.04 is technically 1 plus 0.04. You got to go backwards. Okay, 1 plus 0.04. So then the 0.04, that's a decimal. But how do I rewrite that as a percentage? How do I write that as a percentage? 0.04 is the same as 4%. So it's answer choice D. Yeah. Lauren, you said you got 6 zeros. Let me check. 10 to the power of 7. Hold on, mine's not loading. Oh yeah, she's right. It's B. Lauren was right. I'm sorry, y'all. I counted wrong. I'm sorry.
Wait, what?
So I counted wrong because, okay, it's been a while since I've done this. You don't write 7 zeros after the 10, you write 7 zeros after the 1. So that's the way it works. So 10 to the power of 7 is 1 with 7 zeros. 1, 2, 3, 4, 5, 6, 7. So what would be 10 to the power of 13? How many zeros? 13 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. So you add the zeros after the 1, not after the 10. Okay. Questions on that? I don't think that'll come up, but just in case, now you know.
That's 10 trillion. Yeah.
That would be 10. Would it be 10 trillion? No, because I think 10 trillion would be 10
No, hundreds of thousands.
hundreds, thousands, millions, trillion. Oh, billion, trillion. Yeah, 10 trillion. You're right. Well, you can look on the board. All right, but the most important part of this is the 4%. Remember that the number in the parentheses is a decimal and you have to turn it into a percentage to know the actual percentage. So any questions on that part? If you chose A or C, do you have any questions? Okay. All right. Couple more. We're almost done. I think it's just 2 more. Yeah, we're almost there. So the breakdown of a sample of chemical compound is represented by the function P of T equals 300 times 0.5 to the power of T, where P of T represents the number of milligrams of the substance and T represents the time in years. Explain what 0.5 and 300 represent. So I'll give you a couple seconds to think of your answers. It's kind of an interesting situation, but let's start with the 300. In general, 300 is my what? Yeah, the y-intercept, the starting amount. Now, what is it in this problem? 300 what? Milligrams. So 300 milligrams of the substance. So the initial amount. 0.5, hold on, let me get there. 0.5, in general, this number is my what? Your rate of Is it growing or is it decreasing? Decreasing. So this is my percent decay. And it's a decimal right now. It's a decimal. Technically, if I split this up, this is 1 minus 0.5. So if that's the decimal, the percentage would be good, 50%. And does it tell us the time? How often is this happening? Every day, every minute, every month? Read carefully. Years. So 50% decay each year. So see how we put that all together? You always have to start with what you know. You know it's the initial. Then you look at your problem and you figure out, okay, what am I measuring? You know that the other number is your percent decay. And again, you got to look back to the problem to figure out what units we're actually using. No, on it would be multiple choice on a test. It would be multiple choice, but it's important to know how to find those answers. So questions on this one? We have one more problem. Almost there. How did we know that it was decaying? Because it's 0.5 and 0.5 is less than 1. Less than 1, Lauren. If it was less than 0, it would be negative number. Yeah. Okay. Last one. Genevieve deposited $400 in her bank account. The equation A of t equals 400 times 1.07 can be used to calculate the value of her money after t years. What is the annual interest rate that she is earning? So remember, interest is the same as percent. Think about it. Send me your answers when you have it, and then we'll be done. Yeah, we're looking for the correct percentage. Go backwards. Good. Guillermo's got an answer he sent to everyone. All right. So we're working backwards. So let me write this down. 400 times 1.07. All right. 1.07. Technically, this is 1 plus 0.07. Is that my answer? 0.07%? No, what is it? 7%. You got to turn it into a percentage. So if you chose, if it was like this, and you chose A, you'd be wrong. It is not 0.07%. It is 7%. 7% is her growth rate. Second question, real quick. How much money did she start with? Oh, wait, it kind of says it. But how much did she put into the bank? $400, her initial amount. Okay. So that's it, guys. That is it for today. This is not, sorry, I copied that from an old slide. You do have homework. I already put it up on Teams, so you should already see it. And the homework at this point, you could try it tonight because you have learned everything that's going to be on it. So you can start it tonight, keep working on it, and make sure that you finish it by Friday. Yeah, it's already on Teams, so on period 1 or 7, depending on which one you're in. So if there's no final questions, that'll be it for today. Nice job today. Any questions? No? Any questions? What? Yeah, you see me every day. What do you mean? Yeah. Why not? You don't like it? All right, bye, everybody.